The global race for AI dominance is intensifying, and at its heart lies a hidden vulnerability: data. OpenAI, a frontrunner in this technological battle, relies on colossal datasets to train its transformative models like GPT. But what if the very foundation of this intelligence is flawed? OpenAI's models are trained on a vast array of information, including publicly available data from the Internet, proprietary data obtained through partnerships, and human feedback. This immense scale makes meticulous data collection and bias mitigation not just important, but critical. Consider sampling, the art of selecting a representative subset of data. OpenAI cannot ingest the entire Internet. They must sample. Simple random sampling, where every data point has an equal chance of selection, is a basic approach. It's efficient for balanced datasets and quick experiments. However, for a complex, diverse world, it often falls short, risking a skewed view if the original data is imbalanced. Stratified sampling offers a more nuanced solution. Imagine OpenAI wants its models to understand diverse languages or cultural nuances. They could divide their vast data into strata based on language or geographical region, then randomly sample from each. This ensures representation across key categories, preventing underrepresentation of specific groups within the training data. Systematic sampling involves selecting data points at regular intervals. While efficient, like picking every 100th document from a web crawl, this method carries risks if the data has hidden periodic patterns that align with the sampling interval, inadvertently introducing bias. Cluster sampling divides the dataset into clusters, such as entire online communities or domains, and then randomly selects entire clusters to sample from. This is useful when natural groupings exist, but can introduce bias if the selected clusters are not truly representative of the overall population. Even with advanced sampling, bias remains a silent killer, subtly undermining AI's capabilities. Bias in AI can emerge at various stages, from data collection to deployment. Selection bias is paramount here. It occurs when the training data isn't representative of the real-world population the model serves. For instance, if OpenAI's models are primarily trained on English text from Western sources, they might exhibit less accuracy or understanding for other languages or cultural contexts. Researchers have identified biased text in key sources OpenAI used to train GPT-3, contributing to bias in its text generations. Response bias, another critical concern, happens when individuals respond inaccurately or falsely to questions, often seen in surveys or feedback mechanisms. While less direct for core training data, it can impact how human feedback, used in methods like reinforcement learning from human feedback, shapes OpenAI's models. If human reviewers evaluating model outputs have their own biases or tendencies, these can be ingrained. For example, if users provide feedback that reflects social desirability bias, where they conform to perceived social norms, this could subtly influence model behavior. Measurement bias, or measurement error, arises when the data collected fails to accurately represent the real-world concept it's intended to measure. This isn't about who is included, but how their characteristics or outcomes are recorded. If the metrics used to evaluate OpenAI's models are flawed or inconsistently applied, they might mask underlying biases or falsely indicate fairness. For example, using healthcare spending as a proxy for health needs can lead to biased outcomes if historical spending patterns are unequal across demographics. OpenAI is actively working to mitigate these biases through a combination of data curation, model training adjustments, and ongoing evaluation. They focus on improving the quality and diversity of training data by filtering out toxic content and including broader perspectives. Techniques like reinforcement learning from human feedback help align models with ethical guidelines. Practical strategies include actively diversifying data sources, ensuring equitable representation across demographics and languages. OpenAI excludes sources with paywalls, those primarily aggregating personally identifiable information, content violating their policies, or those that have opted out. They also implement post-training safeguards, such as moderation APIs to detect and block harmful content. Rigorous testing, including red teaming, probes for vulnerabilities and potential biases. The battle against AI bias is a continuous, iterative process, requiring constant vigilance and a commitment to transparency. As OpenAI pushes the boundaries of artificial intelligence, mastering reliable data collection and aggressively avoiding bias is not just an ethical imperative, but a strategic necessity for the future of AI itself.